Welcome to Chapter 8, Day 2, 8.3, Simplifying Radical Expressions. So there's going to be a lot of different types of expressions we're going to be dealing with today, all dealing with radicals. So it is important to know your perfect powers so we can simplify them, and we'll get lots of practice here today. Okay, so let's go ahead and jump in with example 1 here, where we are subtracting two radicals, but what we should notice is our index is 4. So we're taking the fourth root. So right now we cannot combine these terms because they're not the same. In order to combine these terms, we need the same index, which is 4, so we have that, but we don't have the same radicand, which is the value that's underneath the radical. So we have to simplify each of these terms individually before seeing if we can in fact combine them. So I take a look and I say, okay, well, what's the biggest perfect power of 4 that goes into 162. So if you're not so sure, you might just have to go through your powers of 4. So 2 to the 4th, 3 to the 4th, 4 to the 4th, etc. All right, so what you should notice is 81 times 2 is 162. And 81 is a perfect fourth power. Okay, now minus 3 times, I'm going to have to simplify this guy. Now I'm going to use this as kind of a hint. In order to combine these terms, I would need to be left with the fourth root of 2. So if I divide 512 by 2, do I get a perfect power of 4? So 512 divided by 2 is 256. Is 256 a perfect power of 4? And it just so happens to be, yes, it is. It's the 4 to the 4th power is 256. Okay, so I kind of use that as a guide. Now, does it always work? No, it doesn't always work, but that's a good starting point. Okay, so what is the fourth root of 81? Well, the fourth root of 81 is 3, and we are left with the fourth root of 2 minus 3 times the fourth root of 256, we said was 4, and we still have the fourth root of 2. Now, before we can go further, we have to combine or multiply those coefficients. So what we really have is 3 times the fourth root of 2 minus, multiplying those, we have 12 times the fourth root of 2. Now that we have the same exact radicals, same index, same radicand, we can go ahead and combine those coefficients. All right, it's just like saying 3x minus 12x. How many x's do we have? So in this case, 3 minus 12, we have negative 9 fourth roots of 2. And there is our final answer. Moving on to the next example. This time I notice that we have radicals in the denominator. So again, before we can combine by adding or subtracting any radicals, we need to fully simplify each term individually. Now, how do we get rid of the radical in the denominator? Well, what we do is I need to eliminate that square root of 2. So what can I do? I can multiply the numerator and the denominator by the square root of 2. Because the square root of 2 times the square root of 2, we can multiply those values underneath to get the square root of 4, and the square root of 4 is 2. So I'll show you, I'll walk through this. So the numerator of that term becomes 4 root 2. The denominator, we have that 2. Multiplying those two radicals together, we get the square root of 4, okay? Well, the square root of 4 is really 2. So I'm totally fine if you were to just go ahead and rewrite that as 2. Okay, so that should be a multiplying. Okay, and then we still have that plus 7 root 2 over 4. All right, so cleaning up this first term, we can multiply the 2 times 2. And we will get 4 root 2 over 4. Plus 7 root 2 over 4. Now you might ask, well, why don't we just cancel out those 4's? Well, we certainly can, but if you look, we can combine these terms because our radicals have the same index. If it's not there, it's 2, and the same radicand. So notice though, we have fractions. In order to add or subtract fractions, we need common denominators. So I'm going to leave this guy as 4 root 2 over 4. Now we can combine those numerators because the denominators are the same. So 4 root 2 plus 7 root 2, how many root 2's do we have? We have a total of 11 root 2 all over 4. And now I just verified, does 11 and 4 simplify any? And our answer is no. So there we have our final answer. I want you to go ahead and try this next example on your own. Simplify each term individually. Notice there's a radical in the denominator here, so you'll have to take care of that. You should be able to simplify the square root of 48. See if you can combine these terms. After you're done, come back and check. We'll see if you got it right. Okay, did you get 23 root 3 over 3? Let's just go through the process really quickly. This middle term here, I needed to multiply by root 3 over root 3 to get rid of this radical in the denominator. So you can see that note, and we get our denominator to be 3. So this term goes to 7 root 3 over 3, and we're subtracting it. Square root of 48 simplifies, you can see the note over here, as 4 root 3. Now, they all have radical 3, same index, so we're good to go. We can combine these, but we have one fraction, so we need common denominators. So the common denominator is going to be 3, so I multiplied this guy by 3 over 3, and we got 18 root 3 over 3. This middle term was fine, and then I needed to multiply this by 3 over 3, and we got 12 root 3 over 3. So now that the denominator is all the same, we can combine the numerators. 18 root 3 minus 7 root 3 is 11 root 3, plus 12 root 3 is where we get 23 root 3 all over 3. Moving on to this next example here, where we are squaring a binomial. So the rules still apply. Squaring a binomial, we cannot distribute that power because of that subtraction sign. So we can rewrite this. Hopefully you recognize that's like saying 2 minus 4 root 3 times itself, 2 minus 4 root 3. So what we're going to do is we're going to FOIL. All right, so when we FOIL, we just have to remember when we're dealing with radicals, we multiply coefficient times coefficient and radicand times radicand. So I'll kind of walk you through what I'm talking about. So the first is 2 times 2, so we get 4. Then we've got 2 times negative 4 root 3. So the 2 times the negative 4, we get negative 8 root 3. Now we're going to have negative 4 root 3 times 2. So the negative 4 times the 2, so another negative 8 root 3. And now finally these last two terms, negative 4 root 3 times negative 4 root 3, we have negative 4 times negative 4. So that goes to positive 16. Then we have root 3 times root 3. So we can multiply underneath there. So that becomes the square root of 9. Now, if you just jump to saying, oh, well, the square root of 9 is really just 3, I'm totally fine with that, okay? But just make sure that's how we get that. All right, so what we have so far, we can combine those root 3's. So we have 4 minus, that's going to be 16 root 3 plus 16 times 3. And you should be able to recognize that 16 times 3 is going to be 48. So now when we combine everything, 4 plus 48, we're going to get 52 minus 16 root 3 as our final answer. So with that said, I want you to try this next example, okay? It's another foiling, all right, but there's a lot more radicals involved. So remember, coefficient with coefficient, radicand with radicand. So go ahead, try it, and then come back and check your answer when you're done. Okay, check how you did. So 2 root 3 times 3 root 3, 2 times 3 is where we got 6. Root 3 times root 3 is square root of 9. If you jumped straight to saying 6 times 3, that's perfectly fine. Then 2 root 3 times 2 root 5. So 2 times 2 is where we got 4. Root 3 times root 5 is where we got root 15. Then we move in. Negative root 5 times 3 root 3. So negative 1 times 3 is negative 3. Root 5 times root 3 is root 15. then negative root 5 times 2 root 5, negative 1 times 2 is negative 2, root 5 times root 5 is square root of 25. Again, if you jump to 2 times 5, totally fine. We can go ahead and combine these middle terms. We would get 1 root 15, and the square root of 15 is as good as it simplifies. That's as good as it gets. So 6 times 3 is 18, 2 times 5 is 10. Combining 18 minus 10 is where we get that final answer from. This next example, now what we're doing is we're adding and subtracting radicals in the denominator. So we can't just multiply by root 3 over 3 anymore. That's not going to eliminate the radicals in the denominator. So what we do is we multiply by what's called the conjugate, and you've heard that term before. So we need to multiply by the conjugate of the denominator. Okay, so the conjugate of the denominator. And the conjugate of the denominator is simply where we change the sign of that denominator. Okay, so right now it's root 3 minus root 2. We're going to multiply the numerator and the denominator by root 3 plus 2. Okay, over root 3 plus, root 3 plus 2. All right, so notice the signs are different, okay? And now this just becomes a foiling problem. So I'm going to put parentheses around the numerators, and we're going to FOIL the numerators, and parentheses around the denominator, we're going to FOIL the denominator. I'm going to give you a second. I want you to do that portion on your own, then come back and check your answer when you're done. So just FOIL the numerator and the denominator, and then we'll go from there. Okay, so hopefully when you FOILed everything, you got what I did. Root 15 plus 2 root 5 plus 2 root 3 plus 4. Yours might be in a different order, but that's okay. Either way, we can't combine any of those terms because they're not like terms. The denominator, root 3 times root 3, I just wrote it as 3, plus 2 root 3 minus 2 root 3 minus 4. Now let's just go through and combine any like terms. Now what we notice is in the denominator, these guys cancel. So that's what we want, okay? We want those guys to cancel. So we end up with the square root of 15 plus 2 root 5 plus 2 root 3 plus 4 all over negative 1. Now, could we leave our answer like that? Absolutely. But we could just rewrite this as changing the sign of everything in the numerator. So that's like saying negative root 15 minus 2 root 5 minus 2 root 3 minus 4 as the final answer for that guy. Our next example takes us to simplifying these radical expressions with a radical in the denominator, but what do we notice? This time the index is not 2. Okay, so I can't just multiply by the cube root of 4 over the cube root of 4 because that doesn't necessarily give me a perfect cube in the denominator. Okay, but one thing we could do is I notice that 4 can be rewritten, right? So I'm going to rewrite this as 2 over the cubed root of 2 squared. Okay, now why would I do that? Well, in order to get this radical out of here, out of the denominator, I need a perfect cube underneath. Right now, I just have a perfect square. So what do I need to multiply the numerator and denominator by so that I get a perfect cube underneath? Well, hopefully you recognize we need to multiply by the cube root of 2 to the first power. Okay, so if I multiply by 2 to the first power, then what do we get? Well, our numerator becomes 2 times the cubed root of 2 to the first power. I don't need to rewrite that. And our denominator becomes the cubed root of, when our bases are the same, right? What do we do to those powers? 2 plus 1, we get 2 to the third. Okay, now since the index matches the power, remember we could rewrite this as 2/3 to the 1/3 power, and power of a power, those guys multiply, right? So we would end up with 2. So that's how we're able to simplify this guy. So what do we end up with? Well, we end up with 2 times the cube root of 2 all over 2. Now, these 2's cancel, so we can even simplify it further by saying, well, that's the cubed root of 2 as our final answer. I want you to give this next example a try. It's very similar, okay? So I want you to simplify 2 over the cube root of 49. All right, see what you get and check back. Okay, did you get 2 times the cube root of 7 all over 7? Hopefully. So hopefully you recognize that 49 is really 7 squared. So all I need to do is I need to multiply the numerator and denominator by the cube root of 7. All right, when we do that, our denominator will become the cube root of 7 cubed, okay? And now those just cancel. The index cancels with the power, and we're just left with 7 in the denominator and 2 times the cube root of 7 in our numerator. Moving on finally to the very last example, all right? So this looks kind of like the example right above this where we're dealing with conjugates, but I notice I've got fractions within fractions, and that's never fun. So the first thing I want to do is I want to eliminate that mini denominator. So this is called a complex fraction because it's got fractions within fractions. All right, so how do we get rid of this denominator fraction here? Well, if I multiply the numerator by the square root of 2 and also the denominator by the square root of 2, this guy here will cancel. Okay, so we're going to distribute that to each of those terms. All right, and same thing here. We're going to distribute. So 1 times root 2, we end up with the square root of 2 plus 1 over root 2 times root 2. Those guys cancel. So this gets canceled, and we're just left with 1. All over 1 times root 2, we get the square root of 2 again, minus, now 1 over root 2 times root 2, those guys cancel. And so we're just left with minus 1. So now this becomes a problem just like the problem up above where we're using our conjugate. So I want you to finish this problem off by multiplying the numerator and denominator by the conjugate of the denominator. So follow along the example right above, all right, and check back when you are done to see if you got it right. Okay, so did you multiply by the correct conjugate? So you're looking at the denominator and noticing that you're going to multiply by root 2 plus 1 over root 2 plus 1. Now we're just foiling, so root 2 times root 2 is 2, root 2 times 1 is root 2, another one of those, and then 1 times 1 is 1. So this is what you should get for a numerator when you FOIL. When you FOIL the denominator, if you do things correctly, those radicals will cancel out, which they do. So we end up with root 2 times root 2 is 2, and then positive root 2 minus root 2, and then negative 1 times 1 is negative 1. Gathering our like terms, we end up with 3 plus 2 root 2 in the numerator, and the denominator, the radicals cancel. 2 minus 1 is 1, so we can simply write our answer as 3 plus 2 root 2. If you have questions, let us know.